my name is Avinash, and today I'll be teaching you the topic that is dynamics of the connected body, which is the subtopic of a chapter that is Newton laws of motion. Here I've written the short form, that is NLM. So in dynamics of connected bodies, we will learn about if two bodies are connected to a string, or we can say a rod. We will learn to find the tension in the string or tension in the rod. Or if two bodies are accelerating, we will also learn about how to calculate acceleration of that bodies. Okay. So I have taken a basic problem here. We have a ceiling, and from that ceiling a 2 kg body is connected to a string, and a 6 kg body is connected to 2 kg body with the help of a string. Okay. So we can say that here 2 kg and 6 kg both bodies are at rest. In physics, if two bodies are more than two bodies, we can say that is at rest. We can say that the bodies are in equilibrium. So we can say that this is a question based on the equilibrium. So here to solve such problems, our basic question is that the examiner will ask us to find the tension in both strings. So how will we find that? So for that we have to draw a basic free body diagram. And now our basic question arises that what is the free body diagram? So free body diagram is we have to draw all the forces on both the bodies that can be applied here. Like for example, for 6 kg body, one force is necessary force, that is if both are under the influence of a gravity. Of course gravitational force will act, and the gravitational force formula is m into g. So I am writing the simply value. Their mass is 6 and taking the gravity value, that is 10. We can also take 9.8, but to simplify the calculations we will take the gravity value as 9.8 as 10. So we can say that for 6 kg body the weight will be, or we can say the gravitational force, that will be 60 Newton. Okay. And if that 6 kg body is connected to the string will apply a force that will be a tension force. The tension force will be in upward direction here. Because why upward? Because the nature of the tension force is always pulling nature. So the tension in the string will pull the body upward direction, that will be in T. Okay. We have drawn the 6 kg body free body diagram. And now we can find the tension in the string. As we can say, if this body is in equilibrium, means this body is not moving. And if this body is in equilibrium, the net force on the body must be 0. And if the net force on the body must be 0, then we can say that the upward force and downward force acting on the 6 kg body must be 0. So from here, from the condition of equilibrium, I can say that T will be equal to 60 Newton. Okay. Now let's suppose we have to find tension in the upper string. So I have assumed this is T1. In this string, we have a tension T2. So can I consider, to draw the free body diagram, can I consider this 2 kg and 6 kg body as a part of one system? Yes, because both are not moving, both are at rest. So instead of solving for 2 kg, I will take both 2 kg and 6 kg as a part of a system. So can I say that if both bodies are rest, or we can say that complete system is at rest, means net force acting on that system will also be 0. And if net force acting on that system is 0, I can say that the upward force will be equal to downward force. Okay. So for these two bodies, the upward force is T2. And two bodies are a part of a system, so gravitational force will be acting downward. So gravitational force will be acting downward for the complete system. The total mass will be 6 kg plus 2 kg, that is 8 kg. And the gravitational force formula is m into g. That the total mass is 6 and taking gravity value as 8. Total mass is 8 and taking gravity value as 10, that is 80, and unit of the force is, that is Newton. So here I can say that the value of tension in the upward string is 80 and lower string is 60. This was a basic problem. Now suppose we have a system that is having 3 masses. Let's say mass 2 kg, 4 kg and 6 kg block. All 3 are connected through a string, and this we have a upper string. As we can see in the problem that all the 3 bodies are in equilibrium, or we can say that all the 3 bodies are at rest. So now we have to find the tension in each string. So how many string we have in this problem? We have 3 string in this problem. So we have to find tension in each string. So how we will find it? So in previous question I have explained you all that to find tension in string for such problems we have to draw free body diagram. So for the free body diagram we can start from 6. If I am focusing on 6, what forces can be applied here for the 6 kg block? Can I say that if this block is under the influence of a gravity, there must be a gravitational force, right? So the gravitational force will be acting downward here, and that value will be the gravitational value for gravitational force formula is m into g. So here mass is 6 and taking gravity value is 10. So the gravitational force acting will be here is 60 Newton. And here the 6 kg block is connected to a string, and string will apply this block a tension force. And nature of the tension force is always pulling. Means this 6 kg block will experience a tension in upward direction. This will be the direction of tension. Okay. So if the 6 kg block is at rest, or in physics we can say that the 6 kg block is in equilibrium, can I say that the upward force will be equal to downward force? Can I say? So if this body is in equilibrium, so we can say T will be equal to 16 Newton. Here I am considering tension as T1. So from here we can find the tension in the lower string T1. Now we have to find tension in this string that is in the middle. So we can solve this problem by 2 ways, either considering only 4 kg as a mass, or 4 kg plus 6 kg as a complete mass. If we will consider a 4 kg mass, we have to apply the force of the tension of upward string also and downward string also. That will create an extra term. So to minimize our solution, or to reduce the size of our solution, we will consider 4 kg and 6 kg as a complete system. If I consider 4 kg and 6 kg as a complete system, can I say, because both 4 kg and 6 kg is at rest, so we can take both 4 kg and 6 kg as part of a system. Okay. So what forces can we apply to this system? So there will be upward tension force, that will be T2. And if 4 kg and 6 kg is we are considering a single system, then there will also be a gravitational force. But what will be the value of mass? So the mass value will be 4 kg plus 6 kg, that will be 10 kg. So this complete body is in equilibrium. Then we can say that the upward force acting, that is tension T2, will be equal to downward force, and that downward force is equal to how much? Will I take 60 or 6 plus 4, that will be 10 or 100? For T2 we have considered 4 kg and 6 kg as a one system, so the total gravitational force will be 100 Newton. Simple. Now we will find the tension in the upper string. So to find tension in the upper string, let's assume this 2 kg block is experiencing a T3 tension. Either we can solve a problem by considering only focusing on the free body diagram of 2 kg body. But for that we have to apply a gravitational force also, and there will be two tension forces acting in upward direction and downward direction. To reduce such solution or to minimize our size of solution, we will consider the downward mass is 2 kg, 4 kg and 6 kg as a one system. If I consider 2 kg, 4 kg, 6 kg as a one system, can I say that basic question is why I will consider that 2 kg, 4 kg and 6 kg as one system? Because we can see that 2 kg, 4 kg, 6 kg all are in equilibrium. So we can consider all three bodies as a part of one system. So if I consider all these three as a part of one system, I can simply apply an equation that for this system, a force acting is the tension force only acting is T3, and there will be a gravitational force acting downward in the downward direction. So if complete system is in equilibrium, we can say that the value of T3 will be equal to the total mass of the system will be 2 kg plus 4 kg plus 6 kg. That will be 6, 4, 10 and 2, 12. The mass is 12, but the value of gravity we can take 9.8 also. But for the simplicity, we will take the gravitational acceleration due to gravity as 10, and then our answer will be 120 Newton. So in this problem, we have understood to calculate the tension in each string. The T1 value was 60, T2 value was 100, and T3 value is 120 Newton. I think you all got the point. Now suppose if we have a surface, let's consider the surface is smooth surface. We have a block, 2 kg mass, and let's consider another block of 6 kg mass, and both are connected to a string. Okay, if I apply here let's say 40 Newton force. Okay, basic problem. We have a 2 kg block, 6 kg block connected to a string, and we are applying a 40 Newton force on a 6 kg block. So our question is, we have to find the acceleration of the block and tension in the string. So the question is, both blocks will accelerate or not? So we can say that there is a net force. If the surface is smooth, there will be no frictional force, and this complete system is having a force in right direction. So if this system is having some net force, then of course the system will accelerate. So as both bodies 2 kg and 6 kg are connected to a same string, both are the in case of connected body situation, so we can say the acceleration of 2 kg block is A if I consider, and 2 kg is also connected to 6 kg. So as both bodies are connected, so we can say if acceleration of 2 kg block is A, then acceleration of 6 kg block will also be A. Okay, so let's first find the acceleration of this block. So to solve this, to find the acceleration, we will simply apply the second law equation, means the Newton's second law. And Newton's second law is net force acting on the body is equal to mass into acceleration. If 2 kg and 6 kg again having same acceleration, can I consider both as a single system? Yes. And the net force acting is here 40 Newton. Mass of the string is, mass of the blocks are, if we are considering both 2 kg and 6 kg as a single mass system, the total mass will be 8 kg, and the acceleration will be A, that we have to find. And from solving this, simply we will get A is equal to 40 by 8, that is 5 meter per second square. So we have find the first part, that is acceleration. Now we have to find the tension. To find the tension, we can use the free body diagram of any body, either 2 kg body or we can say 6 kg body. So let's consider 6 kg body. So 6 kg body is connected to a string, and string will apply a tension force, and nature of a tension force is always pulling. So this 6 kg block will be pulled by a string with a tension force P. Okay. Now to find tension, can I again apply here the second law equation? What is the second law equation? I will write here. The second law equation is net force acting on a body is equal to mass into acceleration. So what the net force is acting on the 6 kg block? The net force is 40 minus T, because force is a vector quantity and the direction consideration is important. So right direction, our standard sign convention is take right direction as positive and left direction as negative. So 40 Newton force will be considering positive and the tension force will be considering negative. So I can write the net force as 40 minus T is equal to M. What is the mass? That is 6 kg. And what is the acceleration I got? Acceleration we have 5. So 6 into 5, that will be 30. So can I simply solve the equation and get the value of T? So solving the equation, I can get the value of T as 40 minus 30 is equal to T. So value of T will be 10 Newton. Okay. Simply here I can write T is equal to 10 Newton. Will I also get the same answer if I solve for the 2 kg mass? The answer is yes. Because if the string is massless, tension in the string will be same at this point also as well as this point also. So let's suppose I draw the free body diagram of 2 kg body also. So the 2 kg body is experiencing an external force? No. Like 6 kg body was experiencing external force of 40 Newton. But there is nothing here to apply an external force on 2 kg. But this 2 kg body is connected to a string. Will the string apply a force? Yes. String will apply the force, and that force will be tension force, and nature of the force is pulling in nature. So the tension will pull the 2 kg block, and here I will write the tension T. If I also write, so our first step is to draw the free body diagram, and second step is to apply the Newton's second law. So again, if I apply here Newton's second law equation is net force is equal to mass into acceleration. So what's the net force acting on the 2 kg block? That is only tension force. So net force is T, mass is 2, and acceleration value we got 5. 2 into 5, that value will be 2 into 5, that will be 10 Newton. So we can say that if we solve for 2 kg or 6 kg, we will get the same answer. It's your choice. You will either you solve for 2 kg or 6 kg. Thank you very much.